Okay, so today we're going to go into our next lesson with right triangle trigonometry. We're going to talk about angles of elevation and depression, which basically is just a way for us to incorporate story problems, real world applications using this trig. So you're not just going to come across a triangle that you're set up and solve. You have to kind of think about within the scope of your experience there, what exactly could you do with this triangle? How can you set it up? How can you use right triangle trigonometry to solve for missing pieces? So there's two angles we need to know about. We call them the angle of elevation and the angle of depression. And so for the angle of elevation, as we see here, that's the angle formed when we look up at an object. So if we look at this picture here, we got this guy standing off to the side of a tree. Now when he looks straight out, okay, so that's kind of his original line of sight. When he then goes from looking straight across to looking up towards the top of this tree, that angle between where he would normally be looking and where he looks up to see the top of the tree is called that angle of elevation. And so when we're looking up at an object, that angle from the ground or from the horizontal up is going to be that angle that we're talking about. On the flip side of that, the angle of depression. So if we look at an angle of depression, we imagine someone is up higher than the object they want to look at. So if we imagine that there's a person up here at the top of the Eiffel Tower, when they look straight out along the horizontal, they would be looking along this direction. But then if they wanted to spot someone down on the ground off in the distance, they look down towards that object of interest. And so what ends up happening is from that horizontal or natural look to where they look down to the object in the distance, it forms an angle of depression. Now, what's nice about the angle of depression is that we can actually use that angle of depression and we can transfer it down here into our right triangle. If you notice, going from that person straight down and over to the object creates that right triangle that we like. And so based on that, I can use this angle of elevation. So from the person on the ground looking up at the top of the tower, those two angles are the same. So the depression angle and elevation angle should always be equivalent because they're both from the horizontal. So what we're going to do here is, as we're looking at these problems, and then the first example I show you using an angle of depression first, but then I'm going to show you what it looks like using the angle of elevation, which is going to be easier for us. So typically, we are going to use this angle in the bottom every time. Whether it says depression or elevation, we're going to use this angle in the bottom every time we try to solve one of these problems. So if we look at a depression problem, so an airplane is flying at a height of 2 miles above the ground. The angle of depression from the airplane to the airport is 2.4 degrees. What is the distance along the ground from the airplane to the airport? So as we look at the picture that's set up here, this was if we were going to use that angle of depression. So I've got my airplane up here. It's flying essentially in this direction, so it's looking out in this direction straight across. The angle of depression from it down to the airport. So now if we were to look from the airplane down at the airport, the angle that's created, that angle of depression, would be 2.4 degrees. Now, as we're looking at this then, using those two lines, we can create this right triangle as it looks right now. So we could use this right triangle here. We know that the height of the plane is 2 miles. Now, the reason I don't like this is that we have the 2 miles way over here, nowhere close to the airplane. And so the height is 2 miles, and we want to know the distance along the ground. Well, the distance along the ground is labeled up here, which is nowhere near the ground. So while this triangle is nice for identifying the angle of depression, it's really kind of difficult to say label the other sides because they're not along the places that they would normally be, like along the ground or up to the airplane. And so as we look at this picture here can be a little bit confusing. Now, what I'm going to do here is instead, I'm going to do this a little bit differently. So an airplane is flying at a height of 2 miles. So I'm going to draw from the airplane straight down. So from the airplane straight down is 2 miles. We want to find the distance along the ground. So if I'm starting at the airplane and I go along the ground to the airport, I want to find this distance. Now, to me, that right there is easier to kind of see and measure as far as labeling the picture and things like that. And so now I have this right angle, and so if I create this line, I get that right triangle like we want to see. Now, here's where the problem comes in. When I have that angle of depression is on the outside of my triangle right now. So I'm looking at this pink triangle, the angle's on the outside. But on that last slide, we said, well, this angle up top here is exactly the same as this angle down here, the angle of elevation. So if someone was at the airport looking up at the airplane, their angle of elevation would be 2.4 degrees. And so now as far as labeling, the 2 miles and the X are easier to find in the picture. All I have to remember is we always use the bottom angle in the triangle. So whether they say elevation or depression, we always use the bottom angle in our triangle. And so now if I label my pieces, across from the right angle is my hypotenuse, across from my angle is the opposite leg, next to my angle is the adjacent leg. So in this case, I don't have a hypotenuse. I have an opposite and I have an adjacent, which means I would need to use tangent. So tangent of 2.4 is equal to my opposite 2 over my adjacent x. So knowing which trig ratio to use for opposite and adjacent, and then making sure we put opposite over adjacent. Now, since x is on the bottom, we divide. So I'm going to take 2 divided by tangent of 2.4, and so that's where we plug into our calculator. So 2 divided by tangent of 2.4, and we end up with an answer of 47.7 miles. So the airplane is 47.7 miles along the ground away from the airport. So with these types of problems, we are only adding one step to what we learned yesterday, and that is we have to draw the picture to know which pieces of the triangle we have. Then we can set up our equation, and then we can solve. So here's a look at another example. So let's say John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle of the ground to the top of the tree is 33 degrees. How tall is the tree? So with something like this, we might start by, and this is where some of you guys can use kind of your creativity. We can draw our tree. Okay, so I've got this tree. I want to try to find the height of it. Okay, so I want to try to find the height of this tree from top to bottom. And so what they said is John walks 100 feet from the tree. So we're walking 100 feet from the base of the tree. He then looks up at the top of the tree. So as we can look here, we see this right triangle that we create. We got the height, which is what we're trying to find. We've got the distance along the ground, which is the 100. And then we look at the angle of elevation. So looking up at the tree forms a 33-degree angle. And so the very first thing we got going on here is we're trying to figure out what x is over here, the height of the tree. And so we've got our right triangle where the hypotenuse, again, is unlabeled. We have the opposite leg, which is x. We have the adjacent leg, which is 100. And so opposite and adjacent, again, are tangent. So we set up an equation. Tangent of 33 is equal to opposite x over adjacent 100. Since x is on top of the equation, we multiply. So 100 times tangent of 33. And then when I plug that in my calculator, we find that the tree has a height of about 64.9 feet. And so with these types of problems, guys, especially if it helps you visualize, you can be a little bit creative with your pictures. You have to have the right triangle drawn. So if you can visualize that in your head and draw the right triangle on your own, it's going to be the same right triangle every time. So we've got a height, we've got a length, and all of that. But if you want to be a little bit creative with it and actually draw out some of the pieces that they're describing, it can help you visualize which pieces are which within the picture. So I typically like to at least draw a little bit of something in my picture so that I know which pieces are which. So let's look at the next one here. Kiara is flying a kite. She's let out 55 feet of string. If the string makes a 35-degree angle with the ground, how high above the ground is the kite? So in this case, we kind of have the same basic idea here. So we've got Kiara flying a kite. Okay, so she's got a kite at the end of the string. And again, I kind of like to have something for reference here. So I've got her flying a kite. Now, in this case, what's happening then is we're looking at how high above the ground the kite is, so down to about where she's holding it. So we're going to negate the fact that she's holding it a little bit above the ground. So I want the height. This is what I'm looking for. So I have this right triangle formed from the height, the distance along the ground, and then the string itself right here on the where she's holding. And so if I look at the picture, or look at the problem here, it says she's let out 55 feet of string. So that means the string, which is this part of my picture, is 55 feet. It says the string makes a 35-degree angle with the ground. So my angle, which is always in the bottom of my triangle, is 35 degrees. And so now if I look at my picture here, my hypotenuse is 55. I'm given the hypotenuse this time. X is across the triangle, so that's my opposite. And then my unlabeled side would be next to the 35, which is adjacent. So in this case, I have an opposite and a hypotenuse. That leads me to sine. So sine of 35, the angle always goes with the trig, is equal to, when I set up my fraction now, opposite on top, x, a hypotenuse on the bottom, 55. And since x is on top, we're going to multiply. So in your calculators, you're going to take 55 times sine of 35. And so if we plug that in, 55 times sine of 35, we end up with a value of 31.5 feet. So the kite would be about 31.5 feet up in the air. So when you're working through these problems, as you're looking at the worksheet for today, draw the picture first. You have to at least draw a right triangle, label the pieces that they give you in the problem, including the side that you're trying to find, and then set up your trig equation. Tell me if you multiply or divide, so what are you plugging in the calculator, and then give me that answer. And then if you have any questions on any of that, make sure you ask in class or check the answer keys as they become available.